All right, today we're going to pull back the curtain on one of the coolest parts of modern AI, how it actually remembers things. And no, it's not magic, but honestly, what's going on behind the scenes is just as amazing.
You've probably had this happen, right? You're chatting with an AI, maybe you mention you're a fan of a certain project, and then 10 minutes later, it brings it up again totally in context. How does it do that? How does it keep that conversation going?
Well, that ability to recall what you said, to build on your conversation, that's the key to making AI feel, actually intelligent. And it all boils down to a very specific and seriously powerful way of storing information.
So to really get how an AI can pull up what you said 10 minutes ago, we have to look at the process that gives it this memory in the first place.
It's got this kind of techie name, but the idea behind it is actually pretty simple. It's called RAG, which stands for Retrieval Augmented Generation. And really, it's just a framework that lets a language model pull in outside info to answer your questions.
So when you tell an AI, hey, remember this for later, the RAG pipeline is what grabs that info, squirrels it away, and then, here's the important part, retrieves it when it's relevant. This is what turns a simple question and answer session into what feels like a real conversation.
But how does it store that info? This is where we get into the real secret sauce, the core tech that makes all of this possible.
So you know a traditional database, right? Think rows and columns, like a big spreadsheet. A vector database is totally different. It stores information as something called embeddings. And you can just think of an embedding as a long list of numbers that captures the vibe, the actual meaning of a piece of text.
And here is the absolute key to understanding this. Words or sentences that mean similar things get turned into lists of numbers. We call them vectors that are mathematically really close to each other. The AI isn't reading English, it's just comparing numbers to find patterns.
Just look at this table for a second. See the numbers for dog and puppy? They're practically the same. Now compare those to car, not even in the same ballpark. And that's it. That's how an AI knows a puppy is just a young dog, but a car is something completely different. It's not about language, it's just math.
Okay, so we've got these numbers that represent meaning, and they're all stored in a database. But how does an AI use them to find the right stuff when you ask a question? Well, that's where the search process comes in. It's basically a four-step dance. First, you take a big document and break it into smaller, manageable chunks. Second, each of those chunks gets converted into one of those numerical vectors. Third, you store all those vectors in the database. And finally, when you ask a question, your question also gets turned into a vector, and the database just looks for the stored vectors that are the closest match.
And what's wild is that this search is incredibly fast. It uses a really clever algorithm called Approximate Nearest Neighbors, or ANN. It lets the system sift through millions, even billions of vectors in milliseconds to find the most relevant info for your question.
Now, building a system like this used to be a real pain for developers. It often meant juggling multiple separate systems. But thankfully, a much more modern approach is making everything a whole lot simpler.
So in the old days, you'd have your regular database for all your app data, and then a completely separate, specialized vector database just for the AI stuff. You had to manage two complicated systems. The new way? It puts it all together. Your regular application data and your AI vector data can live side by side in one single platform.
And the benefits of doing it this way are huge. It just simplifies everything. It reduces complexity and makes sure all the data works together seamlessly, which means developers can build these awesome AI features so much faster.
Okay, so theory is great, but let's make this real. Let's look at a concrete example. Imagine an IT support ticket system that's built on this technology.
So a user types in their problem. Notice how they phrase it, just plain English. They didn't use any special keywords like VPN or firewall. They're just describing what's wrong.
Now, a traditional keyword search would completely fail here. The word VPN is missing, but because a vector search understands meaning, it knows that trouble connecting to the company network is semantically almost identical to cannot connect to VPN from home. It finds the right solution based on context, not just on matching words. It's a game changer.
And you can probably see, this is so much bigger than just chatbots or IT tickets. This kind of technology is fundamentally changing how all sorts of applications work.
We're already seeing it everywhere. I mean, chatbot memory is the obvious one. But also that smart text search we just saw, finding duplicate documents, getting those creepily accurate personalized recommendations on shopping sites, or searching through huge company knowledge bases.
So if there's one thing to take away from all this, it's this. We are moving from a world where computers just match exact words to a world where they can understand our intent and our meaning. And that is a massive, massive leap forward.
So the next time an AI surprises you, the next time it remembers something you said earlier, you'll know exactly what's going on under the hood. It's all thanks to this clever bit of database magic using embeddings and vectors. And that really leaves us with a pretty fascinating question to think about. If this technology becomes standard, if every application we use can understand what we mean instead of just what we type, what does that unlock? What new things could we build? It's pretty exciting to think about what comes next.